Let us try to evaluate the following integral. The integral of x squared dx divided by square root of, you have 9 minus x squared. Substitution doesn't work here. We're going to use a special type of substitution, trig substitution. In trigonometric substitution, on the denominator, you have the square root of 9 minus x squared. So if you can create something that has 9 next to it, you can factor out 9 and simplify this. We're going to use x equals to 3 sine theta. Why is that? Because if I plug in 3 sine theta to the second power, my denominator becomes 9 minus 9 sine squared. So I can factor out 9 and I can simplify this because, so let me write down the reason behind it. We have 9 minus x squared that can be written as square root of 9 minus 3 sine theta to the second, which can be written as the square root of 9 minus 9 sine squared of theta. You can factor out 9, you get 1 minus sine squared of theta, which in turn can be written as square root of 9 times square root of 1 minus sine squared of theta, or you get 3 times square root of cosine squared of theta, or you get 3 cosine theta. So the denominator can be simplified this way. If you are taking just sine theta, then you don't have the chance to rewrite this in the form of a trig unity and then simplify it. So since x is equal to 3 sine theta, dx is 3 cosine theta d theta. So let us continue. This is the integral of x squared, which can be written as 3 sine theta to the second power. For your dx, we have 3 cosine theta, and we just saw that on the denominator, it is 3 cosine theta, right? So this is a nice integral. Why is that? I can cancel out, don't forget d theta. I can easily cancel out 3 cosine theta, and it becomes a nice integral, which is the integral of 9 sine squared theta d theta. Let me use the same color. 9 sine squared theta d theta that you already know how to deal with. The sine squared of theta, as you remember from pre-calculus, sine squared of alpha in general can be written as 1 minus cosine of 2 alpha divided by 2. So substitute this guy for sine squared. You get the integral of 9 times 1 minus cosine of 2 theta divided by 2 d theta. This integral is equal to the integral of 9 over 2 minus a half cosine. Let's just write down 9 over 2 outside. What do you think, guys? Nine over 2. The integral of 1 minus cosine 2 theta d theta. In turns, this integral can be written as 9 over 2. And then the integral of d theta minus the integral of cosine 2 theta d theta can be calculated separately or together. Either is fine. This is equal to 9 over 2. The integral of d theta is theta minus the integral of cosine 2 theta becomes 1 over 2 sine of 2 theta plus constant of integration. But are we done yet? We are not done yet. We need to make some adjustments, all right? Because our original integral is in x. We're going to use the trig substitution that we used here, copy, paste it here. So we make sure we have all the information. And let me write this guy in distributed form, 9 over 2 theta minus 9/4 sine of 2 theta plus c. So x is equal to 3 sine theta. What's the meaning of that? It means that sine theta is equal to x over 3. But what is sine 2 theta, all right? For sine 2 theta, from pre-calculus, it is 2 sine alpha cosine alpha. So we're going to use this just right here. And please note that since sine theta is equal to x divided by 3, theta is inverse sine or arc sine of x divided by 3 that you can use for theta here. Perfect. So let us write this guy down as 9 over 2 times arc sine of x divided by 3 minus 9 over 4 times 2 sine theta cosine theta plus constant of integration. Okay, so sine theta is easy to recognize. It is x divided by 3. What about cosine theta? So let us use our right triangle. From our right triangle, if you have your theta, your sine x is defined as x divided by 3. So you have x divided by 3. The other length is 3 squared, which is 9, minus x squared. So cosine of theta is square root of 9 minus x squared divided by 3. Use it here. Perfect. So you have 9/2 arc sine of x divided by 3 minus 9/2 sine theta is basically x divided by 3. This is your sine. You already know what is sine. Sine theta is equal to x divided by 3. And then cosine theta is square root of 9 minus x squared divided by 3. Then you can cancel out 9, 3, and 3. And this guy can be written as 9 over 2 times arc sine of x over 3 minus x divided by 2 times square root of 9 minus x squared plus constant of integration. So let us go on top and revisit what we did. We had the integral of x squared dx divided by square root of 9 minus x squared. We used the trig substitution of 3 sine theta. The reason behind it, because we have square root of 9 minus x squared on the denominator. When you substitute 3 sine theta for x, you can simplify this denominator to 3 cosine theta, which goes on the denominator, but at the same time, dx is equal to 3 cosine theta d theta. So basically dx and the denominator, they get cancelled out. You end up with the integral of 9 sine squared of theta. Sine squared of theta, as you remember, from pre-calculus can be written as 1 minus cosine 2 theta divided by 2. So you substitute it here. You can factor out 9 over 2, and you have the integral of 1 minus cosine 2 theta d theta. Separate these two into two integrals and find the integral in theta. But remember that your original integral is in x, not in theta. So you have to go back to the substitution that you used. Your x is equal to 3 sine theta. So sine theta is x over 3. But going back to the definition of a right triangle and the definition of trig functions, sine is x over 3. So the other length is square root of 9 minus x squared. Why we are doing that? Because when we break down sine 2 theta into 2 sine theta cosine theta, we need cosine theta. So cosine theta, which is square root of 9 minus x squared divided by 3, can be substituted here. And then your x, which was 3 sine theta, gave us sine theta x divided by 3, or 3 is the inverse sine of x over 3. We substitute everything, and here we have the solution in x.